Yes, it's my pleasure to introduce Ray Hammat. I've known Ray for many, many years, probably back into the 70s. Ray and I used to work for the PMG, as it was known then, and since then we've been sort of working together on various projects. And yeah, Ray, I think you started out with your father, didn't you, in the engineering field?
Yeah, that's right.
And as he retired, and then you took it over for your own purposes. So that's Ray runs his engineering firm down at the back of the Trade Centre on Marion Road, and I'll let Ray start to talk about these things. And what I'll do, I'll be here just to grab any questions, and I'll repeat the questions back, mainly just for the video. So we're just capturing that tonight, and then we can all hear what the question is. Thanks, Ray.
I haven't seen this before, how you put it together, so I'm going to have to read it myself. That's self-explanatory, I think, so far. That's a piece of 32mm thick steel plate that I started the adapter plate from. I'm not sure what the next one is, but I actually had one side ground, so it's perfectly flat as a datum point. Oh, there it is. That piece of steel weighed, from memory, about 36 kilograms. That's set up on radial arm drill, just drilling the locating bolts and dowels on the gearbox. That's the first step. If you've got any questions, just sing out and I'll stop and answer them for you as we go. Just another shot of the same thing, a little bit closer though. Piece of rag up there is just to stop pieces of metal going inside the differential. I'm sure Eric didn't want it full of metal chips.
Right, this is a question and answer thing?
Yeah.
Can I start with the questions?
Yeah.
How do you locate the holes exactly? I mean, how do you know? I mean, it has to line up with that hole in the gearbox underneath, but...
So the question is, how do you align the holes? How do you work out where the holes go?
Right, first of all, the gearbox is set up on its end, and it's perfectly squared up with the drill, and I locate that point off of the gearbox itself.
Yeah.
Sit the plate on top and then drill through.
All right. Yeah.
Then take the plate off and move it to the next one,
All right.
and then put it back, and then
the whole time.
keeping everything perfectly aligned. So
That's why the bolts are in the other ones to keep it.
yeah, well, they've already been drilled, so they're holding it and stopping it moving. First of all, there's a couple of dowels. I think there's a dowel in that corner there, and another one on the other side somewhere. You drill them first, so that the plate goes back in the same place every time. Can't move. So it's a bit of a slow process, but it's the only way to get everything perfectly aligned. That's it with the dowel holes and the bolt holes. And that's also the centre of the input shaft, which again was picked up off of the gearbox itself and then marked perfectly in the centre, because that's got to align with the centre of the motor shaft when it's all bolted together. This is it set up in the lathe on the faceplate, so all of that whole mass was actually swinging in the lathe off, and it's all out of balance to start with. You've got to balance it before you can actually turn it. And that centre mark is where the live centre is in there to stop it from moving around and just support it. You've got 36 kilograms spinning around at 300 or 400 RPM. if you don't balance it all, and
How do you balance it electronically?
no, just adding weights on the back here in the appropriate place. There's one there. It's better to put it on. Set this up so you can just spin it by hand. And if you've got it out of balance, the heavy part will go to the bottom. So you put a bit of weight on the other side, and so it just free runs on its own.
And if you want to see a video of this actually being turned, it's on my website, on the Barina website, on YouTube.
Okay, now we're up to checking the fit. That's Eric's electric motor. This is all still mounted in the lathe at the moment. Just checking that everything aligns with the motor sitting in the correct position before I take it out of the lathe, in case I've got to trim a little bit more. That's the motor side of the plate after it's pretty much finished there. And that's just a machine surface. There's no polishing or anything else. It's straight off the tool.
So how thick's the remainder of the adapter plate?
The thickness is this edge here. From memory, this one was about 8 mil thick.
So you took off 24 mil?
Pretty much, yeah.
Yeah. Okay.
This is it. That's just another photograph of the same thing, different angle. And that's the inside of it. It's all been hollowed out in here to reduce the weight.
What was the final weight of it?
I believe this one from memory was about 6.5 kilos. Down from 32. So yeah, I made a lot of scrap. That's up to Eric.
To stop it rusting, what I did, I've got a rust removing chemical which I just went over to just to get rid of any surface rust that might have been on it, and then I just simply did a very fine coat of undercoat and then a top coat.
A bit louder, please, Eric.
I just did it basically undercoat and then a top coat, and just very thin so you don't interrupt any of the measurements, and it looks just a silver colour, so it actually looks like it's aluminium in the car. But yeah, just simple steel preparation.
Could you make that out of aluminium, that plate?
Oh, I could, but it worked out. I used steel initially because I couldn't get any aluminium in the right thickness. I had to buy 50 mil thick aluminium and take it down to about 30 mil. So there'd be a lot more wastage, and the cost of aluminium is actually dearer than a steel plate. It's at least double the price.
And also being thicker, it might not have fitted. The motor has only got a very small clearance on the side where the car is, the side of the engine bay. So it might not have fitted being thicker.
Now this is the coupling that goes on the end of the motor. That's the motor there. This is the new coupling, still in the lathe chuck. Just checking it for fit on the shaft to make sure it's. I bored the inside of this to be the correct dimensions, because I don't want more than that, about 1/2 thousandth of an inch clearance. Otherwise it's going to start wobbling and then cause bearing problems and so on. That's the same thing, just a bigger photograph. There's the coupling there. There's a centre in the end of the tailstock here, holding the motor perfectly aligned with that.
And is there a woodruff key or something in there to locate it?
Yeah, you can see that in the lane.
Yeah, there is the shaft is keyed, so it has a key in it afterwards as well, but wasn't at this point in time. This is one with the coupling in place with the clutch centre fitted to it.
It's just temporary fitted with no screws yet.
Oh yeah, that's right. It's only temporarily sitting in there. Each one of these here is actually a rivet hole that held the clutch centre to the original clutch plate, which we got rid of, the clutch plate.
Did you actually spline the shaft for that thing as well?
Didn't need to, because we're using there's a spline in there which fits the original input shaft of the gearbox.
So you flanged the other side, did you?
Yeah, that's a flange there, and steps down to the motor shaft, which doesn't have a spline on it. It's just a keyed shaft.
Is that the weak point? Is that the point where it can break the easiest, the key? Because there's a massive amount of torque. So, is that a weak point?
Keys are very strong.
Keys are very strong because there's no place for it to move anyway.
Question? What was the question, please?
Oh,
Is the key in the shaft, the motor shaft, a weak point?
it's keys in shaft is a traditional method of coupling and providing the locking of a shaft onto an adapter or coupler like this. It's been used for ever since engineering's been around, and as long as they're tight, they never shear off. Because the key itself, the key material, is as strong as the shaft generally. In this case, the coupling is actually made out of the same material that engine crankshafts are made out of, which is a high tensile steel, so that part of it's not going to shear. And because there's no movement in there, it can't go anywhere, it can't shear off. That's another view of the coupling before the holes are drilled to actually mount the clutch centre in there. Just another one at a different angle. Same again. Gives you a bit better of an idea of the size of the various pieces. That's the coupling sitting on the input shaft of the gearbox with the clutch centre in it, and the plate, adapter plate, sitting on top, still sitting on top of the gearbox while it's mounted in the radial arm drill at that point in time, in case it needed to be any other holes drilled, whatever. That's the drilling of all the holes for the mounting the clutch centre. Unfortunately, this one had about 50 rivets in it. So I had to drill 50 holes and then tap them all, because I'd put screws in them.
Can you do the making the threads automatically, or do you do that all manually? Or you can set a thing up on the lathe, can you?
No, this can't be done in a lathe. I do.
The question was,
Yeah, sorry.
can you do the threading of the holes automatically, or do they have to be done manually?
Now, these had to be done manually. I do have a automatic tapping chuck, but unfortunately it wouldn't fit in this drill. Whoops, gone too far. It wouldn't fit in this drill press that I was using to drill these holes. So each one had to be tapped manually. There's the key on the shaft of the motor and the keyway in the coupling. So cut in there. The two slide together. And then there's a bolt that actually goes through into the motor shaft to hold it all in place so it can't come off, can't move around.
It's a tapered shaft here?
No, it's a parallel shaft. That's it. Just fit it up on the motor. That's it, fitted on the motor. There's actually a socket head cap screw in the centre there holding this coupling onto the motor shaft. That's the coupling with the clutch centre in it again. And that's it again with all the screws in it. You see all the heads of the screws there. That's a better shot of it.
Yeah, Ray probably didn't need to use all the screw holes, but they were there, so why not? And now the load is spread across all of those screws evenly. Makes it very, very strong.
That's the clutch centre and the coupling sitting on the input shaft of the gearbox without the adapter plate sitting on it. Just to give you an idea what it looks like without the adapter plate on. As you can see here, that's a dowel, so is that one, and that one is as well. They actually locate the plate to stop it moving around when you put it on. Even if the bolts come loose, they will still hold it in place from twisting. And they have bolts go through those as well to hold it.
Sorry. Can you go back to that picture? Is it very important to get the dowels very accurately aligned? More accurately than the bolts? Because I had that problem with mine.
The question was, is it very important to have the dowels perfectly aligned?
So do you
Yeah.
use a special method to do that?
Oh, same method as I used for drilling the holes,
Oh.
but I started with drilling the holes for the dowels first. Once I got all of the dowel holes drilled, I then drilled the others, and then once that was all completed, then I picked up the centre of the input shaft and marked the plate so that the centre of the input shaft is perfectly aligned in the right location on the plate. So when the motor goes on, it has to be perfectly aligned.
How did you pick up that centre?
Using a live centre in the spindle of the radial arm drill. And when I did the machining of the adapter plate in the lathe, I used that same centre that I picked up here and marked here to give me the central machining point, the centre of it. So when it was machined, and after I finished with it, I checked it with a dial indicator, and I had 0.000 inch run out.
When you had the plate on the gearbox when you started drilling the holes, did you knock the locating things out?
Oh yeah, I took the dowels out so it would sit down flush.
So they knocked out?
Yeah, the dowels, those dowels are just a steel, basically a tapered steel tube, so they go in and they're nice and snug into the aluminium housing, but they do come out for drilling and so on, and yeah. But then you've got to put them back again. That's it all assembled without the motor on it, of course. Another one with the coupling on the end of the motor. Same again. There it is, all assembled, still in the radial arm drill with the motor in place. Oh, I don't remember off the top of my head now how many hours I spent, but it's an awful lot. Eric needed a aftermarket engine mount because the original engine mount, this was a piece of rubber. This is part of his original engine mount, but there wasn't an awful lot of rubber in there because the petrol motor doesn't have a lot of torque that's transmitted through this when you take off in first or second gear. It's only electric motors that have the massive torque when you're first moving off, and this needs to be strengthened substantially to handle that torque and not allow the motor to twist itself out of the car, basically.
Go to the next one and see if
Just another shot of the same. It's a two-sided piece of double-sided piece. That's actually two pieces, then they're pressed in together, one from each side.
yeah. So a bolt goes through the centre of the red part, and you'll see one of the next
Bolt goes through there as well.
The next photo shows it in situ in the car.
Is that neoprene?
Polyurethane, that is. There's a lot of different grades of polyurethane. They'll handle different loads depending on what the requirements are. The grade of this polyurethane is what they call 60 Euro, which is similar strength to rubber, but because it's a complete solid thing, it will transmit a lot more energy than what rubber will.
So did you machine that to size as well?
Yeah, that's when I machined all that as well. I started with a piece of, the diameter of that is approximately 75 mil in diameter. So I started with a piece of 75 mil diameter bar, probably about that long, and machined it out. Okay, this is an engine mount bracket. This end of it here, this end goes on the end of the motor. These 4 bolts here bolt onto the end of the electric motor, and these 2 bolts here go up to that bracket that we just saw a moment ago.
See that. And the 2 little holes, just mention those 2 little holes.
The 2 little holes are there for putting a tacho mount on the end of the motor. Because on Eric's motor, he's got a double-ended shaft effectively. One comes out this end, which the tacho pickup is on, and the other end obviously goes to the gearbox. That's 6 mil steel plate, that one, and I forget what the length of that is now, Eric. Do you remember?
About a foot.
300 odd mil long. I took these pieces out of here just to lighten it down. It's not done for any other reason other than to drop a bit of weight. Could have been, it was originally round. That was all round. Again, I machined all of this. This bit here I oxy cut though. Take that out. Those 3 pieces there. That's it in situ in the car. There's the 2 polyurethane pieces. There's the bolt through. That's the part of the vehicle, and there's the top of that bracket with the 2 mounting bolts through there.
While you're on that photo, because there is so much torque on this applied to this bracket, let me have a pointer for a sec. This is originally the centre of this was what do they call that welding? Spot welded to the rest of the bracket. And what happened was those spot welds fractured because of all the torque. Every time you take off, the thing would go. So it would just fracture those spot welds, and I had to get it welded, properly welded, continuous weld, each side all the way around. And now there's no problem. So it's just an amazing amount of torque on all these bits. So it's something you don't think of. I didn't think of it. I didn't think it was going to happen. I thought, we've got these nice strong bits in here now. Of course, you know, this bit doesn't move now. And so with the motor trying to move, it's going to put stress on any other part in here, which it did. So sorry about the photo, but it's in a very awkward position to try and photograph.
Is that the only mounting point to the chassis body?
The question is, was that the only mounting point to the chassis or the body? It's actually that end of the motor was supported in the same way. Of the engine, the original engine was supported in the same way. There is support at the other end
On the gearbox.
There's two. There's a two torque bars on the end of the gearbox. Yeah. Oh, and also I think the gearbox is supported underneath with a rubber support. Yeah. Right underneath. There's a support right underneath.
There's another two engine mounts as well.
Not on
That
this
one.
Not on this one. Not on mine. No. Oh yeah, that's just looking. That's looking down.
That's the bracket down
That's
there.
it. And there's a bolted onto the motor there. That's it.
That's the end of the electric motor there.
Yep. So I just painted it black so it'll disappear.
Trust everyone can read that. This is just a mounting bracket that I made for Eric's Hall effect sensor for his tacho.
It's a standard tacho sensor available from JCar. It's just interrupted by a metal or no metal. So you get a pulse every time the metal disappears from the sensor. And that's what you do.
That's the interrupter that each of these slots breaks the magnetic field as it's passing around. So you get 2 pulses per revolution to run the tacho. That fits on the end of the motor shaft. Oops, gone too far. That's another view of it. Just it's got a grub screw there. It just locks it onto the motor shaft. Slightly out of focus that one, unfortunately.
I'll just have a bit of a discussion on the tacho with the original Holden Barina. Of course, with the engine, it was a spark plug type distributor, and what they did, in the old days, they used to just take a wire from the positive side of the coil and take that to your tacho. And like hundreds of volts of spikes there, and they just use those to make your tacho work. So, not having an engine anymore and not having a distributor, I had to recreate the 100 or so volt pulses, and I did that with a little circuit which I found on the net, which is nice and handy. And it's just like a single transistor with a transformer with an open circuit secondary, and that produces the nice big pulses, 2 per every revolution, exactly the same as the original engine. So I'm now using my original tacho, which is great. Yeah, the intermediate drive shaft support in the Holden Barina. They thought, oh, we can't, because where the gearbox is, the shaft going to the left-hand wheel was going to be shorter than the shaft going to the right-hand wheel, and if you leave it like that, you get torque steer. So when you put your foot down, your steering wheel gets grabbed out of your hand. And so what they did, Suzuki, who made the car in Japan, they decided they were going to have the same size shafts both sides, and so they actually have a split shaft on the right-hand side. So you end up with another joint, and then it's supported so that the final drive comes from the same size shaft each side, same length shaft each side. And Ray, because the engine is no longer there, the engine had the bracket mounted on it, and of course the motor is completely different now to the engine, so Ray made a special bracket to support that centre of that driver's side shaft. And it's actually mounts that side, that end there.
That one
mounts on the adapter plate, if I remember rightly.
3 bolts there.
Yep. Special angle and everything.
And it's not square. It's not supposed to be. Otherwise it doesn't fit. I think from memory it's 10mm thick plate, that one, because it's got to hold that drive shaft with all that torque going through it, so it has to be very rigid. So it has to be very rigid. Now this one's not Eric's anymore, this is Paul Hunter's Lotus Elise adapter and coupling that I made for him.
Sorry about the measurements.
Didn't have a proofreader, hey? This is set up exactly the same as I set Eric's up on the radio alarm drill initially. Use a spirit level to get it somewhere near square and then check it afterwards. It's bolted to a face plate, to an angle plate there. There's just a wedge under there to hold it in place until I've got another bracket on it. Gives you a rough idea how it's set up though. That's the original clutch plate in there as well.
Not so many rivets.
No, not as many rivets in that case, in that one. Yeah, this one was a bit bigger. Overall the gearbox was bigger this way, but it also needed to be thicker as well. So we started with a 50mm piece of steel this time. It weighed 44 kilos. That's ground on one side, this side to be perfectly flat as well before we start. The outside shape's been oxy cut to match the profile of the bell housing on the gearbox. Yeah, I can do that, yeah.
What's the maximum depth you can cut with an oxy like that?
The question was, what's the maximum depth you can cut with an oxy like that?
Pretty much that's about it, 50mm with the gear that I've got. They can go thicker, but 50's about the limit that I like to go.
That's really neat. Is it finished off anyway, or is that?
No, that's just straight off the oxy around the edge. But this surface here's been ground. That's the same piece set up after it's been drilled, set up on the faceplate and the lathe. That's the centre where the shaft will go, and all the bolt holes are already in there to mount it onto the bell housing. And that line there is where I'm going to cut it out as well to hollow it out. Oh, sorry, this side here, it's actually, this gets machined down here, down to that line. Checking it with a dial indicator, make sure everything's perfectly aligned. Again, in this case, rotating this around on this centre, I had absolutely zero run out. That's checking it again after I'd actually done some of the machining here. This piece now here is, instead of being 50mm thick, I've taken it down there. That's only, I think it's 8mm thick from memory.
Just confirming, run out is basically wobble, isn't it?
It means it's perfectly aligned, so there is no wobble.
Yeah.
Yep. That face plate that I've got there that's bolted onto is 600mm in diameter. This is it, turned on the outside, and then I'm starting to bore it out to accept the motor in the centre. And that's it, pretty much finished as far as the turning's concerned. Still got to have bolt holes drilled for to mount the electric motor on there yet. That's the inside of it as well. It's back in the radial arm drill to have the holes drilled for the mounting the electric motor. And there's the holes for the electric motor. This is a much bigger motor than what Eric's vehicle was fitted with.
The 10.5-inch Kostov European motor. Very big.
What dimensions we use?
6.75. 6.7.
44 kilos down to about 9 3/4.
That'd be a lot of swore.
A lot of scrap, yeah. Yes, I didn't pick the motor up by hand. I used a 1-ton chain block to lift it up.
What's the purpose of the vehicle? Is that's helicopter sort of?
The question was, what's the purpose of the vehicle? The vehicle was a Lotus Elise, so it has to go fast.
Right.
Yeah, there's no question about that. And that motor go fast.
Is it for flood racing or something, or is it just a road car?
No, it's road car.
Actually, I've got a photograph here of
How does that compare to the Roadster tyre?
It looks the same as the Tesla Roadster.
Yeah, the question was how does it compare with the Tesla Roadster? This car was built a long time before the Tesla Roadster was even thought of, probably.
that's the vehicle there.
It doesn't go quite as fast as the Roadster,
You can pass it around if you like. Have a look.
but it gets close.
Along with these others. Wait till maybe we
Spins its wheels like the
Get through.
tyres on the car are like 10 or 11 inches of touching the road, and it still spun the wheels in second gear. So,
actually, Paul Hunter, when I was talking with him after he got it on the road, he said he put it in third gear and then took off, put the pedal to the metal, so to speak, and he spun the wheels in third gear from a standing start. And I said, be careful, because wherever the weakest link is, that'll be where it breaks. And it wouldn't be part of anything that I built. I can assure you, I made sure of that.
Could I just ask what the configuration? Have they got a mid-engine, those things?
the question is, where's the engine in the Elise? It's just between the back wheels, in line with the back wheels. Yeah.
Yeah, I never actually saw the vehicle after it was up and running. He promised to bring it around, but he never did.
Give you a drive.
No, I never got a ride in it or a drive in it. I never even saw the vehicle, only that photograph that he sent me.
And now it's in Victoria somewhere.
Yep. Yeah, this is similar. That started out as a 13 kilo piece to make the coupling out of for Paul's. There we are, there's the clutch centre sitting in the start of it.
Did Paul have to get a new clutch centre?
Oh yeah, he gave me the original clutch that came out of the vehicle. When I pulled it apart, took the rivets out of it, the rest of it all was badly worn, so I had to throw it away and he had to go and buy a new one. So, because otherwise, the first time he drove it, he probably would have broken the clutch centre.
think getting a racing clutch would be preferable?
Oh, I would think so, yeah, for sure. Yeah, especially if you're going to, you know, be a bit of a lead foot.
Well, I'm not even thinking of that, just the sheer fact that you've got, you know, maximum 4.0 RPM, that's a lot of stress.
Oh yeah, anything that's in, if it's built for racing, obviously is built a lot stronger. So yeah, if you don't want to have problems down the track, put something in to start with that's going to last, you know, without giving you dramas.
And also particularly if you're going to be using your clutch pedal, which both of these cars, they haven't got clutch pedals. But if you have, you know, you need a very, very strong clutch for that engagement, otherwise you'll just strip it. A lot of people have been a lot of people, you know, have to change their clutch plates regularly on EVs if they haven't got a very strong one to start with.
Drilling again for bolts. This time not as many as Eric's though. Yeah, I only put 4 bolts in that one. I mean, the rest are all drilled and tapped, but I just only fitted 4 at that time for that photograph and make sure it all fitted. This is another vehicle. Components. This is the original engine mount that came off the petrol motor.
Yeah.
Is that correct?
Yeah, oh yeah, couple of motors, yeah. My gearbox, sorry, yep.
Of which he tore apart.
Yep.
So I've replaced it with a polyurethane. I used the inner from that original one and the outer as well. Ripped all the rubber out and replaced it with polyurethane of the right grade.
So it's a liquid one?
Well, it was liquid, but it's poured hot at about 140 degrees C. Sits in an oven for minimum 24 hours to cure. That's the original, that's the replacement. Fitted, ready to bolt into the vehicle. Wonder who that is. Okay, looks like that's the end of them, unless you've got some questions.
That Kostov you used for the project, was that actually brought in here into Adelaide? Like, is there a supplier from here in Adelaide, or?
Sorry, say that again?
The Kostov motor. Obviously you had to get it from somewhere. Did you get it from like AEVA Works from Western Australia, or?
Yeah, the Kostov motor was available from AEVA Works
Right.
in Western Australia.
Okay. So there's nobody actually dealing with those motors here in Adelaide?
No, no one at all.
Is that made in Russia? Yeah.
Yeah.
Bulgaria.
Yeah, somewhere like that. Bulgaria.
Bulgaria, Hungary, one of those.
Yep.
I think Bulgaria.
This is probably a very naive question, but why maintain a gearbox in an electric vehicle? Why not use electronic speed control?
The question was, why maintain a gearbox in an electric vehicle? In a front-wheel drive car, the gearbox also has the differential. So if you take the gearbox out, you've then got to create some sort of differential and possibly a reduction drive as well. You can buy them, but they're fairly expensive. And the beauty of leaving the gearbox in is that you can select a gear appropriate to the speed. For instance, in my little Barina, the first lot of stuff that you saw being made, I take off in second gear, and then I just put it into fourth gear once I get up to about 50, 60 k's. And then that's basically all I use. So yeah, that's basically the reason, just so you can select a gear for a particular speed.
Do you have to downshift them?
Downshifter, if I come up to if I slow down for some reason, I'll often just put it back into third, because if going from fourth to third is very convenient rather than going from fourth to second, which is really inconvenient. And then once I get up to speed again, I'll just drop it back into fourth. There's no clutch involved, and you just basically use it like a switch. You just put it in, bring it through the centre. You can sort of feel it against the gate, and it just drops into the next gear with no crunching.
And you get more regenerative braking that way?
In the DC, the question was, do you get more regenerative braking? With the DC system, you don't generally get any regeneration. There is special DC systems, low voltage ones that you can, called SEPEX systems, but generally the DC motors don't give any regen. The problem with that is that you get excessive sparking when you try and do that. Yes.
Yeah, I've noticed you've used manual gearboxes in both the vehicles that you've shown up here.
Yep.
And you've got the clutch obviously, so it is a manual. Why can't you go with an automatic? Can you do that?
Automatics, you can use automatics. In America, a lot of them use automatics, and there's certain automatics you can use and some you can't.
Okay.
But I haven't gone into that, and I don't know of anyone in Australia that's used an automatic.
Yeah, there is.
There is?
AEVA Works are doing a dragster 1 tonne ute at the moment, Holden 1 tonne. They're using twin warps in line. They're using a 2-speed power flight or similar. They've removed the torque converter. That's the key. You've got to get the torque converter out, and they've revalved it to manually switch between ratios. So basically they've got a straight through and an epicyclic gear chain for reduced gearing. So they've got a low speed epicyclic and a straight through, no torque converter. If you use torque converters, just rob too much power out of an
So they've made an automatic into a manual.
Yeah. You can use the gearbox as the point.
Any other questions?
Yes, so what if you were to, let's just say you remove that torque converter idea, that concept, can you use a flywheel in there? Adapt the flywheel to help with the torque of the motor and all that?
The flywheel won't make any. There's no advantage using a flywheel.
Oh, you don't want a flywheel in fact.
Actually slow you down.
Yeah.
Acceleration.
Yeah.
The flywheel for the internal combustion engine will wind up.
Yeah.
And you get the torque for the electric motor. The first quarter turn, basically, you get maximum torque.
Okay.
You don't need any mass to generate the engine.
Otherwise it's all you need, so.
With a lot of the measurements, not specifically to do with the plate, but things like your bracket for the drive shafts, those measurements, were they taken with the motor and stuff in situ, or after everything was pulled out?
Okay, the question was, were the measurements for the various bits and pieces, particularly the intermediate shaft support, were they done in situ, or were they done, how else were they done?
I'm trying to remember now whether you actually measured them before you took the motor out.
I think I might have. I think they were measured before I took the engine out. Actually,
You did have some measurements.
no, I did bring the. I took the components to Ray, and we could put them in the gearbox, and basically work out where the support had to be from that. So it was sort of a. I think it was mainly that. I think it was just from those components that I brought to you. That I brought the drive shaft over to Ray's place, and then the measurements worked out from that. Yeah. Because it mounts on the adapter plate, so we had the adapter plate all finished, and then just had to put the drive shaft in. And yeah, it was like the angle that was shown there. It was just a really strange sort of angle. It must have just been the way it was mounted on the engine, and so you had to adapt to that sort of strange angle to get it to go in the right spot. Yes.
Yeah. Why 8mm stick?
The question.
10 or 5 for the plate.
The question was why 8mm thick? Why not 5 or 10?
Well, that was to give enough strength to handle this massive torque that these motors put out. We didn't want twisting the adapter plate because of the massive torque. I mean, depending on which motor you're talking about, the torque out of these motors is many times greater than it is out of a petrol motor. I don't know what the figure is now off the top of my head, but you've got to make it bulletproof basically, so that nobody can damage it, you know. I know people got fast cars, they actually put the pedal to the floor, you know, sometimes. So you've got to make it so it'll handle all that. Otherwise they come back and say, hey, it broke. For whatever reason.
There's another reason I think where you need to go a bit bigger than 6mm is that because the motor is basically hanging on that plate is stopping the axis of the gearbox and the motor from bending. And I think 8mm would be as thin as I'd want to go, simply because there's a lot of weight in that system.
Oh, that's
suspended on the back of the gearbox and the back of the motor, and so it's all hanging on that. All the resistance to flexure is taking place at that plate that you've just spun. So I wouldn't want to go less than 8mm and be sure that I wasn't going to be trying to flex the bearings of the motor and the input shaft of the gearbox.
Yeah, Edward just mentioned the fact that it's got to support the motor without bending, and the Kostov motor was around about 80 kilograms, I think. So I think the mine motor was about 37 kilograms. Yeah, there's a lot of weight in it, so you've got gravity against you as well as the torque.
Tell me, why can't you use a rear-driven vehicle and put the electric motor straight on the tail shaft?
The question was, why can't you just use a rear-wheel drive car and then put the motor straight onto the drive shaft? Edward's done that with his Subaru L wagon, and is not having any problems with that at all. When you do that, you've got to take into account the fact that you're applying a lot of torque through no gearbox to the wheels, so you've got to have a very, very powerful motor, a very, very powerful controller, and very, very big batteries. So, yeah.
Very full drive cars have that. A Lexus is 690 volts AC on the rear motor. On the front motor, it's memory only 415. So it gives you an idea of how you've got to manage the torque. AC simple as well.
Yes.
Well, like a material, you put it with the speedo. You've got a speedo drive.
Oh yeah, the speedo comes off the gearbox.
Yeah, and you've got a reversing contactor, so you can do that.
Yep, all those sort of things. So the gearbox is very, very useful. Reversing contact, speedo connection.
There's also another reason too, just from the safety aspect. If something goes horribly wrong, specifically with DC motors, let's just assume it just goes flat out, something fails and the thing's flat out, your brakes can't pull it up, disengage the transmission.
And let it blow to pieces, yeah.
Yeah, but
You can also push the big red switch.
you could do that too. But it is another safety mechanism, potentially.
Oh. Yes?
How do you get on if the motor's got a spline arrangement?
How do you get on if the motor's got a spline arrangement?
No, it's just another process of having to cut a spline in the coupling that goes onto the motor first before you put it in. In the case of these two that I've just shown you, they only had keyed shafts. I'm doing one at the moment which has got a spline on it, so it's a matter of cutting the spline in the coupling to match the motor shaft.
Can you go the other way if you had the motor just had a keyed shaft and you wanted to put it into a spline? Can you cut the spline in the end of the shaft? Yeah. Does that?
The question was, if you could, is it true the other way around? You have a splined motor and you want to create a keyed shaft on the motor and create a spline shaft drive.
Yeah, to fit into it. Say you've got a double-ended universal joint with female splines, you want to put the motor into that. Anything's possible. Is that possible?
So you're suggesting one needs to cut a spline on the motor shaft, is that what you're saying? Well, yeah, it can be done. Again, that's a fairly expensive way to go because you've got to pull the motor apart to do it.
Right.
You can't just cut a spline on the end of the shaft while the motor's fully assembled. You actually got to pull the motor apart to be able to do that.
Right. Are there motors with splines and shafts?
Yes, the Siemens motor has a 24 tooth, 25mm spline shaft output.
I've done 3 conversions now, and in every case on the end of the motor I've used taper locks as well as the keyway, and I found that so far that they've worked very well. Have you considered that?
Oh, that's just another way of doing it. The way I've done it with these was I was trying to keep everything as short as possible. When you put a taper lock in there, you need extra length as well. So that's okay if you've got plenty of room, you can stretch things out a bit. I was keeping everything as compact as possible. As in Eric's case, he only had 25mm or thereabouts room to play with, so we had to keep it as short as possible. Same with the Lotus, had to keep that as short as possible. If I put a taper lock in there, I would have had to probably add another 20 or 30mm in there to
I didn't go that have to be that much. I was able to wrap my my coupler over the taper lock to some extent, so I only had to have about 8-9mm of actual extra length on the taper lock, and then unbrake those into the mounting of the taper lock.
Yeah, it depends on every motor and gearbox combination is different, so it depends on the shaft, on the input shaft on the gearbox, depends on the motor shaft as well, so it's a combination. I mean, I've had a lot to do with taper locks in the past. I've seen a lot of them come undone. They make a bit of a mess when they come undone. That's one of the main reasons I've chosen not to go there. I'm not sure how people are going to drive these vehicles, whether they're, you know, quarter throttle, half throttle or full throttle most of the time. So, you know, I err on the side of caution and I make something that works that I know is not going to fail. Because I've seen taper locks fail in the past. They're okay in certain situations, but where you have no control over the load going through them and so on, yeah, I tend to like to stay away from them.
Mine uses a similar taper lock to Ted's, and I'm wondering if you get any warning of failure, or is it catastrophic?
The question was, Richard's is a similar method using a taper lock as Edward does. Do you get any warning of failure, or does it just...
Usually if they come loose, they start making a bit of noise, which is as long as you're listening for it, you know.
Okay.
I know several people, not with electric vehicles, but certainly with petrol vehicles, and one's a relative that I choose not to associate with for an obvious reason. She was driving her car home and the motor started making a really horrible noise, so all she did was turn the radio up louder so she couldn't hear it. She got another 2 k's down the road and seized the motor up, so, you know, it depends on what you're doing at the time, whether you're actually listening for it or whether you hear it or not, you know, and whether you can save it before it destroys itself. Any more questions?
Just a final one to you then, Eric. Can you say something briefly about the energy efficiency of the conversion that you carried out?
Energy efficiency of the conversion. Compare it with a petrol engine. I think a petrol engine gets around about...
Or compared with an all-electric vehicle that wasn't a conversion.
Ah, well, not a lot of difference. They're around about 85% normally, an electric vehicle. But a petrol car is about 15 to 20%.
Yeah. Okay, I understand that. But I mean, roughly what size is your battery and how many kilometres you get?
Oh, okay. My Barina has got 132 volts worth of batteries at 90 ampere hours. I've got just just under 12 kilowatt hours of battery. So it's a lot, even less than a Mitsubishi AEVA. And on a summer's day, I'll get about 80 to 85 kilometres of range. On a bad winter's day, I might get 65. So the batteries like to be warm. The lithium-ion batteries enjoy being warm, and the car seems to go much better in the summertime.
Air's less dense too.
What?
Air's less dense too.
There you go.
What was that?
The air's less dense in the summer.
The rolling resistance of your tyres would be less in the summertime when they're warm as well.
There you go.
Just to clarify the question, or the answer to the question, compared to the AEVA,
Yep.
because you gave 80 kilometres, 12 kilowatt hours is 150 watt hours per kilometre.
That's about right. I have got better than that, but
And the AEVA is around about 130 to 145.
yeah, I have had on some trips I've got 120. So it just varies. Depends on the
Because
day.
you've got no regen.
No, that's
So
right.
you're doing well without regen.
Yeah. Well, it is probably a lot lighter than the AEVA as well. Mine's only 820 kilograms.
The open road, what would you get out of that speed-wise?
Speed-wise, in my little Barina, 100 kilometres an hour. Yeah.
How long does it take you to charge the batteries in your Barina if they're fairly flat to fairly full?
I've got nearly 12 kilowatt hours and I charge at 3 kilowatts. It's about 4 hours.
4 hours?
Yeah. No more questions?
Could you put it on overnight? Could you sort of come home and turn itself
generally it plugs in and when the J tariff starts up at the moment 11:30 at night, it starts up and charges, and then by the morning it's all gone off and I just go out there and it says full on my gauge. It's full each morning, so it's good to see. Yeah. Any more questions for Ray?
Doesn't look like it.
Oh,
Let's-
okay.
Yep.
I've got one. For those who are interested, what would now be the cost of doing the adapter plate and the coupling and, say, 2 brackets for a conversion of a similar nature to Eric's
The question was, what would it cost to make these bits and pieces
today?
today?
For a similar vehicle to Eric's, I can't even remember what I charged in. Such a long time ago.
It was.
What's it cost now?
Well, again, material costs have gone up since then, obviously. Electricity costs have gone up. Everything's gone up. So I
think it all depends on how many hours it takes, basically.
it comes down to the number of hours as well. Depends on the complexity of the whole thing. It's a bit hard to even guesstimate now, and I can't remember what I charged you for yours. It's how many years have you had it on the road now?
Since 2010.
So it's been on the road 5 years. So, and I can't remember what I charged you for it now.
I think the costs are on my website if you want to see on EV RIC.
It depends on the complexity and the cost of materials and so on. You know, it's as to the number of hours involved, and to get the precision that I get, it takes a little longer than. I mean, I could do a slap it together and real quick, but that's not the way I do business anyway. But you'd come back in 6 months and say, "Hey, look, it's broken," and neither of us need that.
I'm just wondering if it would be cheaper or dearer if the owner helped you.
Well, yeah, you pull the gearbox out and you take the oil out of the gearbox and you bring the motor in and you bring the gearbox in and the associated other bits and pieces, clutch.
Taps and threads? Or?
No, that one I'll do myself, because it's if you break a tap and you've got to throw it away and start again, it's a lot more expensive.
Just out of curiosity, were they M6s or 8s?
In the case of Eric's, I think they were about...
What was the question?
The question was what size screws were used to hold the clutch plate to the coupler.
Oh,
In the case of Eric's, I'm fairly certain they were 5mm screws. And there was
That's
about...
why it's good to have lots.
Yeah, lots
Very
of
small screws.
And that's why there was about 50 of them, so lots of chances to break a tap.
yeah.
Unfortunately, I didn't break any.
Ray, you said at the start aluminium was too expensive, it was too much waste, you had to buy them too thick a chunk.
In case of Eric's, yeah.
If you did use aluminium, what would you go down to? You'd go to more than 8 mil at the end?
Oh yeah, it'd have to be.
The question was, what size do you use if you use aluminium?
Depends on the grade of aluminium. There's the readily available aluminium is a 60 series aluminium, which is just, there's nothing special about it. Most things are made out of the 60 series aluminium. You've got to go quite a bit thicker because there's no real, it's not a high tensile material. There is a 70 series material, which is a high tensile aluminium. That you can go a lot thinner, but again, it's dearer. It's a matter of tossing up, you know. In the case of the 60 series aluminium, I wouldn't go under 12 mil.
Use 12 with the fair.
12 would be a bare minimum for a 60 series. If I was using the 70 and I could get it at the right price, I'd probably go down to because the 70 series is about the same strength as, well, from memory, the 70 series has a tensile strength of about 40 to 45 tonnes tensile. The 60 series is only probably 15 to 18 tonnes.
I asked you the question, but not
So,
for the high tensile one, but just for ordinary aluminium. It's not that difficult to make for your own.
But it'd be thicker.
Yeah.
it'd have to be a lot thicker, yeah.
It's not a difficult process to.
The question was, why not just make it out of aluminium? But if it's going to be thicker, it might not fit in your engine bay. So you've got to watch all those sort of things.
I'm just thinking, if it was out of aluminium, you'd get maybe 2 kilogram weight savings on a typical sort of combination. I know it's how long is a piece of string.
The question was, would you save on weight if you did use aluminium?
Yeah, well, you probably will save, but your cost of aluminium to start with is going to be dearer. So you've got to toss up whether you want to prepare to pay, you know, a few extra dollars for the material for a couple of kilograms of weight savings.
Does it make machining quicker?
No, sometimes aluminium can be actually terrible stuff to machine. It tends to pick up on the end of the tool, and then if it starts doing that, it tears the aluminium instead of actually cutting it.
If you're trying to lose weight, it's often easier to, rather than worrying about that, is I found with the Fiat, just by taking the rear, because the rear engine thing, taking the rear bonnet off and making a fiberglass replica saved me 9 kilograms.
Wow.
It was a very cumbersome thing. It's a double thickness because it was air vented and it had to stop water getting into the motor when it rained. And so, you know, sometimes you can pick up weight savings in much simpler ways.
Yeah.
So, you know,
Make that out of a solar panel.
Any more questions? Let's thank Ray for
well, yeah.